Good morning, students. Today we are going to do the second part of the divisibility rules. That is the divisibility of 3, 6 and 9. So let us see what is in store for us. Now students, before we start today's lesson, let us quickly go through what we have learned the previous day. That is the divisibility rule of 2, 5 and 10. Observe the video carefully and then see whether you are able to remember all the rules or not.
In this lesson, we're going to go over the divisibility rules for the numbers 2, 5, and 10. To know if a number is divisible by 2, all you have to know is that it ends with an even digit. And our even digits are 0, 2, 4, 6, and 8. So if it ends with any of those numbers, you automatically know that the number is divisible by 2. So let's look at these examples right here. Can you tell which ones are divisible by 2 just by looking at the last number? 12. 2 is an even number, so it's divisible by 2. 21. It ends with a 1, not an even number, so not divisible by 2. 40. It ends with a 0, so it is also divisible by 2. 15. You're right, it's not divisible. What about 34? 34 is divisible by 2 because 4 is an even number. And 58, yep, also divisible. Alright, a number is divisible by 5 if it ends with a 0 or a 5. So looking at these numbers right here, can you tell which ones are divisible by 5 just by looking at the last number? 15, yep, 15 is divisible by 5. What about 33? Nope, it's not. 110, yep, ends with a 0, so 5 will go into it evenly. And 20, yep, also divisible by 5. 52, nope, doesn't end with a 0 or a 5. But what about 150? Yes, it's divisible by 5. And the last one, probably the easiest one, is 10. A number is divisible by 10 if it ends in a 0. So all you have to do is look at the very last digit, see if it's a 0, and you automatically know if it's divisible by 10 or not. So let's look at these examples right here. You probably figured out the oddball, which one doesn't fit in with the rest of them. Alright, so 340, definitely divisible by 10. 470, also divisible by 10. 215, nope, doesn't end with a 0. So that means that this last one over here, which ends in a 0, 1,790, is divisible by 10. And those are your divisibility rules for 2, 5, and 10.
Now divisibility rule of 3 is little different from that of 2, 5 and 10. Here you have to check the sum of the digits whether it is divisible by 3 or not. Now let us consider the number 2316. So first we have to find out the sum of the digits. That is 2 plus 3 plus 1 plus 6. Let us see what happens. Now as you have seen on the slide, the sum of all these 4 digits is equal to 12. And we all know that 12 is divisible by 3. So 2316 is divisible by 3. Isn't it easy? Let us consider another example. 5729. Let us add the digits. So that is 5 plus 7 plus 2 plus 9. Let us see what we get. Now the sum of the digits is equal to 23. Now 23 is not divisible by 3. So 5729 is not divisible by 3. Now we are going to learn divisibility by 6. Now divisibility rule of 6 is a combination of 2 and 3. That means when a number is divisible by both 2 and 3, we say that the number is divisible by 6. Now let us consider the number 2316. So first we have to find out the sum of the digits. That is 2 plus 3 plus 1 plus 6. Let us see what happens. Now as you have seen on the slide, the sum of all these 4 digits is equal to 12. And we all know that 12 is divisible by 3. So 2316 is divisible by 3. So that was the divisibility rule of 3. Now let us consider the same number and check the last digit. Now the last digit has an even number, that means it is divisible by 2. So 2316 is divisible by both 2 and 3, and hence it is divisible by 6. Now divisibility by 9 is very similar to that of 3. So when the sum of the digits is divisible by 9, then we say that the number is divisible by 9. Let us look at the example. So let us add the digits of the example, that is 6 plus 5 plus 3 plus 4, and we get 18. Now 18 is divided by 9, so we can say that 6534 is divisible by 9.
Let's look at divisibility by the numbers 3, 6 and 9. First, we look at divisibility by 3. A number is divisible by 3 if the sum of its digits is divisible by 3. Is 25,722 divisible by 3? This number has 5 digits. Let's add them. 2 plus 5 plus 7 plus 2 plus 2. 2 plus 5 is 7. 7 plus 7 is 14. And 14 plus 4 is 18. So the sum of its digits is 18. Is this sum divisible by 3? Yes, 18 is divisible by 3. Hence, this number is also divisible by 3. If the sum is not divisible by 3, then the number 2 is not divisible by 3. Let's zoom out and understand another divisibility rule. Divisibility by 6 is not the simplest, but it's definitely very interesting. There are just 2 simple conditions. We can say that a number is divisible by 6 if the number is even and is divisible by 3. Both these conditions have to be satisfied. It has to be even and it has to be divisible by 3. Since the test is a bit different, we will look at 2 examples. The first one is 479,623. Is this number even? Since the last digit is not divisible by 2, this number is not divisible by 2. Hence, this number is not even. So we don't need to check for the other condition here. Even if one of them is not satisfied, the number will not be divisible by 6. Here, it's not even and hence will not be divisible by 6. Consider 190,116. This number is divisible by 2 as the last digit is divisible by 2. Hence, it's even. The first condition is satisfied. Now we check for the second condition. We check if it is divisible by 3. A number is divisible by 3 if the sum of its digits is divisible by 3. So we find out the sum of the digits. 1 plus 9 plus 0 plus 1 plus 1 plus 6. 1 plus 9 is 10, plus 2 is 12, plus 6 gives us 18. the sum equals 18. So it is also divisible by 3. Hence, this number is divisible by 6. Now we come to the final divisibility test of this video. The test for divisibility by 9 is similar to that of the test for divisibility by 3. A number is divisible by 9 if the sum of its digits is divisible by 9. Is 2,479,401 divisible by 9? The sum of the digits equals 27. Since 27 is divisible by 9, this number will also be divisible by 9.